Okay, so the topic of our presenter this time is about internet protocols, packet firewalls catching, cellular networks, the 3G and 5G at the LTE. So in networking, a protocol is a standardized way of course, doing certain action and formatting data so that two or more devices are able to communicate with and understand each other. So to understand why protocols are necessary, we need to consider the process of mailing a letter. So on the envelope, addresses are written in the following order. So name, street, address, city, state, and zip code. So if an envelope is dropped into a mailbox with the zip code written first, followed by the street address, followed by the state for a postal to work. In the same way, all IP address or all IP data packets must present certain information in a certain order, and all IP addresses followed a standard format. To give us more details about let us all welcome the presenter.
Okay. Good afternoon to everyone. So this is my report for our subject, Enterprise Architecture. I will present the lesson 6, which is all about Internet protocols, including HTTP, FTP, SMTP, TCP/IP, and SOAP or SOAP. We'll also talk about packets, firewalls, and caching, and also cellular networks, include 3G, 4G, WiMAX, LTE, and 5G. So let's talk about first internet protocols. So including HTTP, FTP, SMTP, TCP/IP, and so. So our language is very different from the language that a computer uses. So the messages that we create need to be translated from an alphabetic text into an electronic signal before they can be sent. This translation is handled in the computer by the separate modules in the communication protocol. So because these protocols or rules of conduct usually communicate with 2 or more modules, they are best described as layers in a stack of protocols. So these layers are the application layer, the transport layer, the internet layer, the link layer, and the physical layer. So the messages that we send are filtered through these layers, specifically in the transport layer, and they are broken down into small chunks of data, and these chunks of data are called packets. So it all starts in the application layer to create our message. So one example of a protocol from the application layer, which is what programs like the web browser directly interact with. So this layer has protocols like HTTP if you are visiting websites, and or it will be SMTP if you are checking your email. So the transport layer then uses the transmission control protocol or TCP to encapsulate the data blocks from the application layer, where they can individually take the quickest route over the internet to get wherever it is they are going. It then moves to the internet layer, where the internet protocol or IP is used to deliver the packets. And these packets are delivered through the link layer, which is an internet cable, to the physical layer, which is uh, the basic hardware of your computer network. Okay. So the computer that receives these data packets moves them through the protocol stack in a reverse order, so that the message can be reconstructed and understood by the user. So in conclusion, Internet protocol is a set of rules governing the format of data sent over the internet or other network. We can also say that every computer that is connected to the internet runs the internet protocol. The internet can be defined not only by this network of computer networks, but also by being a network that agrees on at least one thing, and that is the internet protocol. So now let's talk about HTTP. Let's have a quick review of the meaning of the word HTTP. Let's have this one as an example. Um, all the words, phrases, and the sentences in this example we have they have normal text, okay? Whereas in hypertext, some of the phrases or words, sometimes the picture, have hyperlinks, right? These hyperlinks, so usually, sometimes they are colored blue, or they're called font color is blue. There are phrases, they are the phrases that can navigate us to other pages. So hypertext is a series of text documents that are linked to each other via hyperlinks. So HTTP, so by meaning, is a protocol, okay, to transfer hypertext. So hypertext transfer protocol is protocol to transfer hypertext from the web server to our web browser. So you can load it up, view it inside your browser, click the link, and then navigate to other pages. Next, we have simple mail transfer protocol. Right? SMTP is basically a set of commands that authenticates and directs the transfer of email. So as an example, when you write an email using an email client such as Microsoft Outlook, and then when you hit send, the email travels from your computer to your email server using the SMTP protocol. Now, this server is also known as the SMTP server. And this is what's configured in your email client. So, for example, if you're using Gmail, the SMTP server address would be, again, smtp.gmail.com. And then your SMTP server will send a message to the recipient's email server also using the SMTP. Then the email will stay on the recipient's email server until the recipient logs into their email account and downloads the email. Or they can just view the email or on the server by using webmail. Next, we have file transfer protocol. So file transfer protocol is a standard protocol that is used to transfer files between computers and servers over a network such as the internet. So FTP is a language that computers use to transfer files over a TCP/IP network. So for example, if someone anywhere in the world wanted to make their files available for other people to download, all they would have to do is simply upload their files to the FTP server, and then other people anywhere in the world can simply connect to that FTP server and download the files using the FTP protocol. Now, in this example, this person is using dedicated FTP server. Okay, so to share their files, but they don't necessarily have to set up a dedicated server on an FTP, because if they really wanted to, they can also configure their own computer to act as an FTP server. For example, in Microsoft Windows, this can be done using the Internet Information Services Manager. Okay, next we have Simple Object Access Protocol, or SOAP. SOAP is a standard protocol transferring data or message across the internet. Web services are remote entities. They use SOAP to transmit data to and from clients. Clients can also be a web service. SOAP is a lightweight protocol intended for exchanging structured information in a decentralized distributed environment. It uses XML technology to define an extensible messaging framework, providing a message construct that can be exchanged over a variety of underlying protocols. XML, or extensible markup language, is almost similar to HTML, and HTML is used to display the data, while XML is used to store and transport the data. Next, we have firewall. So a firewall is a system that is designed to prevent unauthorized access from entering a private network by filtering the information that comes in from the internet. A firewall blocks unwanted traffic and permits wanted traffic. So firewall's purpose is to create a safety barrier between a private network and the public internet. So that is firewall. Okay. Next, we have caching. So there are sometimes that we had a problem with our computer and someone told us to fix it by clearing our browser cache or DNS cache. But what is really caching? So simply put, caching means to store frequently demanded things closer to those asking for it. So by doing that, to increase the access speed. So caching is simply saving some parts of your application so that if you visit again the website or the application that you have downloaded, it can you can increase the access speed. So yeah, for the example, when you visit YouTube, your browser knows nothing about it. So it downloads all the resources that make up YouTube. It can be retrieved from cache, making the web page load much faster because your browser only needs to download newer content that it hasn't been seen before. So that is caching. Okay. So next we have the cellular network. So cellular networks, we all know the generations of cellular networks coming from 0G up to 5G, which is the latest today. So 0G so refers to the pre-cellular telephony technology in the 1970s, and they are considered to be the analog type of networks, like also 1G. And the 3G to 5G are considered as digital. So again, 0G refers to the pre-cellular telephony technology in the 1970s. By mobile telephones in this generation were usually mounted in cars or trucks. Okay, so it is car-mounted telephones. Okay. So in 1G, 1G uses FDMA or frequency division multiple access. So FDMA allows multiple users to send data through a single communication channel. So its speed is around 2.4 kbps and it is around 1980s. So these are the examples of um, 1G type of phones. Okay. Next, we have 2G or the second generation. It is launched in Finland in 1991, and they are usually in this generation they are for text messages and picture messages. So they are considered as numpad phones, and their speed is around 64 to 144 kilobytes per second. Next, we have 3G. 3G introduced in 2000, typically called smartphones. Okay, in 3G we can have video conferencing, some games, 3D games, and usually on this example, the first iPhone, it is a touchscreen phone. So its speed is around 144 kilobytes per second and up to 2 megabytes per second. Next, we have 4G or LTE. So these are the next to the latest, okay, na phones. They are also LTE or their speeds is 100 megabytes per second up to 1 gigabit per second. And we have the 5G, which is still a latest generation, and also the still experimental up to this day. Some of the companies are already adapting to the 5G networks. Okay, almost everyone is now in 5G networks, but this 5G network has a speed of 1 up to 10 gigabytes per second. So those are the cellular networks, and those are the generations of our cellular networks as of today. So those are my reports, and thank you very much for listening.
Okay. So again, the the caching, of course, helps with improving efficiency by storing frequently used data. And in this way, cache content is served from the edge servers without the need to fetch it. No? So how about firewall caching? Caching helps with improving efficiency by storing frequency used data. No, frequently used data. This way cache content is served from the edge servers without the need to fetch it from the origin. And you can manage caching use rules directly on the control center by going to caching policies page. Now, by default, actually our website firewall will catch certain pages of your site to improve the speed and experience for your users. So you can disable actually caching here if for some reason you do not want to happen. No, it is not recommended since it can slow down the user experience. So how about the security risk? No, the security risk of caching, no, is good for performance and convenience, but there is a flip side, no, the security, because web caching is a typical example of security is equal to 1 multiplied by convenience. That is, there is a security cost for use convenience, exposing your web application to potential security threats. So what does caching means in networking? As what our presenter mentioned, no? It is the process of storing data in a cache. The cache is the temporary storage area. When you return to a page, you recently look at, the browser can get to files from the cache rather than the original servers, saving your time and saving your network the burden of additional traffic. So a cache server also refer to a cache engine is type of network service that save internet content and web page locally. No, so the cache also ensure users can access web content while online, including rich media files. A cache server is also commonly used as a proxy server. So a while ago, our also presenter mentioned about the web caching in HTTP. So web caches reduce latency and network traffic and thus lessen the time needed to display resource representation. So HTTP caching makes website more responsive. And again, the primary purpose is to increase data retrieval performance by reducing the need to access the underlying slower storage layer. So trading of capacity for speed, a cache typically store a subset of data transiently, in contrast to databases whose data is usually complete and durable. So I think that's it for our topic for this afternoon.